Now, we want to talk about projectile motion. And as you listen, God bless you. Now, when we talk about projectile motion, now let me define it here. The projectile motion is a what? Is a motion of a body launched into space. Now, when you launch it into space, with what? The influence of what? Gravitational acceleration, and what? Air resistance. Although air resistance, but we can say and negligible air resistance. So because we're not going to be considering what they call it, air resistance in this particular chapter. So when you launch a what? When you launched a what? A particular what body into the space, and you notice that the what is under the influence of what? Of gravitational acceleration and what? Air resistance, we see what? That body is undergoing what? A projectile motion. Now, a simple example of a projectile motion is something like this. Let me just a sketch. Cut it. This is what? Launch it by what? This and give it a what? An initial velocity. So this is what I want to have like this. It means that what? The parts, traced by a what? A projectile motion. Projectile what? Motion is known as what? Known as trajectory. The path traced by projectile motion is called what? It's known as what? It's called a trajectory. It's known as trajectory. And what? The shape. And the shape is what? Parabolic. Please take note of that. What we are having here is parabolic shape, but the part that is traced by projectile, because it is under the influence of what? Of gravity. Although we are going to be neglecting air resistance, will be neglected, but gravity will be influencing the what? The motion. Now, every projectile motion, every what? Projectile what? Projectile what? Motion is what? Independent of what? Two. Every projectile motion is independent of what? Of two what? Motion. Every projectile motion is what? Independent of two motion. Number one is what? The vertical motion. Motion with what? Changing acceleration. Changing what? Acceleration. With what? A vertical motion with changing acceleration with a what? Velocity. What? Changing what? Uniformly. So that means that what? We have number one, that's what they are independent of vertical motion with what? Acceleration is what? Changing. Or let me say constant, sorry. It's a constant acceleration. It's a constant, sorry, it's not changing. A constant, what is acceleration that is constant for vertical motion? G equal to what? 9.8 meter per second square, or what? G equal to 10 meter per second square. So during vertical motion, this acceleration is constant, but velocity is what? Changing uniformly. So that means the vertical motion, acceleration is constant, while velocity is changing uniformly. So that's why I say the vertical motion with what? Constant acceleration, and what? Changing what? Velocity changing what? Uniformly. And what? Velocity changing what? Uniformly. So that is how it what vertical motion is. Now what about the second one? because I told you they are independent. Every projectile motion is independent of two motion. Number one is what? The other one is what we call horizontal motion. Don't forget, for any professional exam, you see them mentioning this. Horizontal motion with what? With zero what? Acceleration and what? Uniform what? Velocity. That means constant what? Velocity. Constant what? Velocity. So that means in what? This part of motion, G is what? 0 meter per second. The second of that for this horizontal motion. That means it's not affected by gravity. That's what I mean by that. So for the horizontal motion, what is horizontal motion now? That's what I'm saying now is that there's a what? A motion like this, and there's a motion this way. So it's as a motion, as a projectile is what? As the body is projected, there are two motions that what? That is, controlling it, but they are independent of them. This one is what? 1 and 2. Now, these two motion now, when you throw a body up on it from here, projected at an angle. Now, let me show you something. As the body is projected at an angle, the time it will take from here, look at this, from A to that, if I need to move like this, the time it will take, they will spend the same time. So that means that if a body is moving like this and the body is moving like this, they will both have the same what? Time. That means they will get to this point at the same what? So that's what I'm saying. That means I have a body moving like this now. Look at it. Look at it. They will all get to this place at the same time. Because why? This one is not affected by gravity. Why this one is affected by what? Gravity. So that is how it works. Now, we want to now look at what? The motion now. Look at it. Look at the motion. Now, let us look at it critically now. Now, this is what? Theta. Projected at an angle, what? At a velocity of projection of u. Now, when t, please take over. When t is equal to 0, your what? Your initial velocity along the vertical, or the velocity along what? Velocity is what? U sine theta. And this one is called what? Let me call it the initial what? Velocity. I told you that in my previous video. I told you anytime you have u, it means that u is initial velocity, and it shows that what? It occurs at times what? T equal to 0. So now this is what? The what? Initial vertical velocity. Initial what? Vertical what? Velocity. Then what is the second one? Initial or horizontal velocity is what? U cos theta. Oh yeah, let's see now. Resolve this one into what? Resolve it into the vertical axis. Yes? Don't forget that angle theta is what? Angle of what? Projection. Angle of projection. Angle of projection. So if you project it what? At an angle of projection u with the velocity of u, if you resolve this one here, become what? The vertical becomes what? U sine theta. Why the horizontal will be what? U cos theta. That is it. At t equal to 0. But what about at t not equal to 0? What about at t is not equal to 0? At t not equal to 0. What do you have? Now we are going to have it as what? Vy. For me, let me change my marker. I want to have what? Vy is equal to what? Uy minus gt when t is not equal to what? 0. Now look at the board. Now uy is what? What are uy? U sine what? Theta minus what? Gt equal to what? Uy. What about vx? Vx equal to what? Ux minus gt. That's weird. But g is equal to what? G equal to what? 0. For what? Horizontal what? Motion. Abi? G equal to 0 now. So if you put G, this one will not cancel now. Abi? So that means Vs equal to what? Us is what? U cos what? Theta. So for horizontal motion, your final velocity along the x-axis is equal to what? Initial velocity along the horizontal component. That means initial here and the final velocity here along the horizontal is the same. It does not change. Another thing again you have to understand here is the displacement. Displacement. I've talked about the displacement. Now, at what? T not equal to 0. We know that our displacement is equal to what? X, y equal to what? Ut minus what? Half gt squared. That is formula for it. Then this one is what? Uy. So what is my uy now? Uy will now be what? Sy equal to what? U sine theta times t minus what? Why is it minus? Because it's going against what? Yes, under the influence of gravity. So this one not what? G what? T squared. It's not true. Now, what about xy or xx? Ss is equal to what? Ux times t minus what? Half gt squared. Now, if this is the formula for that, don't forget that g is equal to what? Equal to 0. So this one will cancel. Abi? So what we have now is what? S equal to what? Ux times t. What is ux? Us is what? U cos theta times what? T. So please take note of that. This formula also very important. This one is what? S. Very important. So we have talked about what? That Vs equal to what? Us. We have talked about what? This is the final velocity along the vertical. Final velocity along the vertical. So that means if I want to calculate the final velocity along what? Any position with respect to time, I use this word. The vertical velocity rather. I want to calculate the vertical velocity. This is not final velocity. Vertical velocity. If I want to calculate the horizontal velocity, which one value? I'll use this formula. Whether initial or final is the same formula. When t is not equal to what? 0. So now, but the next thing we want to do is what? According to the, sorry for that, we want to talk about what? The motion of what? The next thing is what? Motion of projectile as a parabolic what? Parabola. Motion of a projectile as a parabola. That's what we want to discuss now. Now, we want to look at motion of a projectile as a parabola. Now, we know we said SS equal to what? U cos theta times T. Listen up. Now, if what you make T subject of formula, T equal to what? SS over what? U cos theta. Now, take this one as equation 1. Now, XY is equal to what? U what? Sin theta times T minus half what? GT squared. Now, there's something I told you that when a body is projected, if you project it like this, and what? You project it like, if you go through this means and go through me, they have the same what? What I say they have the same time, Abi? So that means time to what? To go from here to this place is the same time. Let me draw it well. Sorry for that. It's the same time to go from here to this place. So since the time, that means this time here along for the horizontal component or horizontal displacement or distance is equal to time at vertical displacement. So that means I can substitute my time here. That's what I mean by that. If the time to go from A to B is the same time to go through this curve too. So let me substitute this one here. That means XY is equal to, let's say Y, let me use Y now, equal to U sin theta times T minus, in place of T now, let me put what? Class. Let me use as S. S over what? U cos theta. Anywhere where I see T, I put that one there. Half, then G into like a what? Class. What do you have here? S over what? U cos theta all what? Square. Now look at this. We have gotten to a point where it becomes what? Now interesting. X will come out. U can cancel U. So we have X what? Tan theta minus what? Minus what? Gx square over what? Over what? 2U square cos square theta. Cos square theta. That's what I want to have now. is equal to y. But remember, I want to what? Remove this the coefficient of this what? Inverse. What is the inverse of what? Inverse of minus g over what? 2u square cos square theta. I want to make x stand alone. So multiply by what? Multiply both sides. Multiply both sides by what? Inverse of what? This, which is what? Which is 2u square cos square theta over what? Minus g. So that's what I want to multiply. So if you multiply both sides by that, what do you have? I want to have it as what? 2y u square cos square theta, that's for this side, over what? Over minus g. That's what I want to have. Yes, now. So then equal to what? This one, if you multiply by that, what do you have? X times what? Sin theta over cos theta times what? What do you have there? Let me clear this side. That we can see how it's spread better. So this one will now give us what? Multiply by this one, we're going to have what? 2u square cos square theta over what? Minus g. Now, this one will now give us what? Minus what? S square. That's what I have done now. So we are going to have S square now. So now, let me what? Work with this one now. This one will now become plus. Sorry, it now become plus. Look at it now. If I multiply this one by minus 2u square cos square theta over minus g, it will cancel out. Just like when you multiply 2u square cos square theta over minus g. Minus will cancel minus g. This one will cancel. We have only s square. This one now become plus now. So that is plus. So let's write it like this now. This one become s square minus what? Can anything cancel? Yes. This one will cancel this one. What again? What again do we have here? There is what? Okay, nothing there. So I would have what? 2u square. Let me write it. U square 2 what? U square 2 sin theta cos theta over g. That means this minus now. That's what I put in here. Then this s will now be here now. X is equal to what? 2y u square cos square theta over minus g. Now, we have gotten to this point. Now, this is a what? A quadratic equation. Now, if I bring this one here, it becomes quadratic. But let me perfect the square. How do I perfect the square of this one? Let me perfect the square of this. So what we're going to do to perfect the square of this is to what? Divide this one by what? 2. Let me first of all, don't forget that 2 sin theta cos theta is what? Sin 2 theta in mathematics. Don't forget. So if I put it there, I would have s square minus what? U square sin 2 theta to replace this one. S over G. Now, which is same thing as what? 2y square, 2y u square cos square theta over what? Minus G. Now, what do we do? Now, to perfect the square of this, to perfect the square, you divide this number, the coefficient of x is x now. You divide it by just where you have what? S square minus what? Bs is equal to C. How do you perfect square of this one from normal mathematics knowledge? What you are going to do is to divide by 2 and square it and add it to both sides. So it now be what? S minus what? B over 2 all square is equal to what? That means I will divide it by 2. They put it what? There. They square everything. They will now say C plus. I will now add it here. I've added it here. But what am I going to do here? I will now say B over 2 all square. That's what I'm going to do there. So that's what I want to apply there. Is a imperfect square. So you are going to put B over 2. That means divide this one by 2 and square it. The coefficient of x divided by 2 and square it. That's what you are going to add to that place. If I open the bracket, you are going to have S minus what? BS plus what? B over 2 all square is equal to C plus B over 2 all square. If you cancel this and cancel one, you see go back to the original function, which is what we are having. Now let me continue. So what I'm going to do now is what? Divide this one by 2 and square and add it to both sides and square it. So this will now be s minus what? U square sine 2 theta over what? 2g. I will now square this one like this. Then I will add it to this other side. So now be what? If I add it, I will now have what? 4. If I add it here, don't forget there is 2 here, which I have turned to that. I will now add it here. What am I going to do here? I will now put what? U square sine 2 theta all over 2g all square minus what? 2u square y cos square theta over g. That's what I would have. Don't forget that there is a s here. Then this one is got to what? Now, I haven't done that. Now, what I want to do now, what will now be this one now? This one will now be what? What we now have is what? Let's say, what is common both sides? Now, that's what question I want to ask now. What is common on both sides now? I want to ask you. Now, something is common on both sides. But let's bring minus out. Don't forget that this one now is same thing as what? U raised to power what? To make it clear. Do you know this one is same thing as what? U square 2 sine theta. Let me take it back to normal. Cos theta over 2g all square. That's what I'm saying. Minus 2u square y cos square theta over what? G is equal to what? X minus what? U square sine 2 theta over g all square. Now, I haven't gotten that. Now, what I want to do now simply is to what? Is to break this one down. What is common on both sides now? Let's factorize. Let me bring minus out. I'll bring minus out. I'll bring this function out. I want to leave y here. So what do I have now? Let me clean this part. So if I bring the function out, what do you have? Let me write that other one first. S minus what? U square sine what? 2 theta over 2g is over 2g, sorry, all square. Then this part, what is common on both sides now? We are going to have it as what? Minus 2u square is common. Then cos square theta over what? Over g. I write this one first. Then remaining y minus. If you bring what? This one is what? The same thing as what? This one is the same thing as what? U raised to power 4 or u square times u square. This one is what? Sine square theta. Cos square theta. Then this one is 4. That's what it means. I'm writing it out times 4 over. Then this one 4g square. That's what it means. So if I bring this out now from here, we bring this one out, bring the 2 out. What will remain? 2 is going out from here. So remaining 2. This one is going out. That one is gone. Then u square is has gone out already. So remaining what? U square. Then sine square theta is remaining. Sine square theta is remaining over what? G has gone out. So remaining g. So I would have what? 4g. That's what I would have. So in that case now, this one will be what? S minus what? U square sine 2 theta over g over 2g is equal to what? Minus 2u square cos square theta over what? Over g into bracket what? This one will cancel, 2 will cancel here 2, 2 here 2. So I would have what? Y minus what? U square sine square theta over 2g Now, if you look at this equation, there is a square here, please. This is what? If you compare it to what? X minus x mass all square is equal to what? 4a into what? X minus ym. This is equation of the parabola. This is what we call the latus what? Retum of the parabola that we have gotten. This is equation of what? Motion of what? Of a projectile. This is the latus what? Retum. So the latus retum of the parabola is equal to what? Of the projectile is equal to what? Minus 2u square cos square theta over what? G. The second of that, if they ask you what is the latus retum, that is the latus retum of the projectile. The latus retum have been what? Gotten of the projectile. So that is latus. What about the xm or the ym? Ym is the maximum height of the projectile, which is equivalent to this one. If you compare them, this is 4a, this is equivalent to 4a now. If you compare this and ym, which is what? H max, maximum height, is equal to u square sine square theta over what? 2g. This is the maximum height of the what? Of the parabola. The maximum height of the curve, of the parabolic curve. Then what about the what? The x. This is the horizontal distance at the maximum. I will show you, which is equal to what? Range at maximum. At maximum. Which is equal to what? U square sine 2 theta over what? 2g. So if I draw the parabola now, look at what I want to see, because I want to end this section. In the next section, now we are now going to look at what do you call it? The different cases of what? Of projectile. Now, this one will now what? Go like this. Now, this particular curve of the parabola, this one, yeah, is what? The maximum height, y max of the parabola. Which is this one. Now, the maximum height. This from here to this place is also x max from here to here. Don't forget that the x max multiplied by 2 is equal to range of the parabola. The range of the parabola is equal to what? From here to this place is your range, your full range, your horizontal distance of the what? The projectile. So in that case now, of the parabola rather. So in that case, your range is equal to what? X mass R equal to x mass times 2. So if you do that, you are going to have what? If you multiply it by 2, you are going to have what? U square sine 2 theta over g. So this one is your range. Your range. So this is what? Maximum what? Height. That is maximum height. This is your range at maximum height. That means from here, from the point of projection at an angle theta to this point of maximum height, is what we call what? X max. This is y max, which is called the what? H maximum from here to here. So you see how they link up now. Now, another thing again you must note, in this case now, in this case, you must know something here. The time to what? If this one, the time to go and return is coming from what? The point of level of projection, in return back to the level of projection. So your H1 is equal to 0 meter, H initial equal to 0 meter. That means H initial is 0, H final is 0. So if you use this word formula, H1 minus H naught equal to U sine theta times T, I give this formula, minus half GT squared. If you use this formula now, this one is what? 0. Then this one is what? U sine theta. Let's use capital letter T as gives me B as a time to represent time of flight. Minus half what? GT squared. If you factorize this one, what is common? C is common. So what will remain? U sine theta minus what? T is common now. Now be half what? GT or equal to 0. If you have this kind of question, let's say you have what? A let's say you have what? S into bracket S minus A equal to 0. For example, in mathematics, S will be 0, you say S equal to 0, or S minus A equal to 0. That's how you solve it. So in this case now, we say what? T. You say T is equal to 0, or, excuse me, or U sine theta minus half GT is equal to 0. Now, let me explain. T equal to 0 occur here. That means when the motion is what? Is about to start. That means at the point of projection. Then T equal to what? What we want to look for now is we can get it from here. So what do we do? Now see what? U sine theta minus what? Half what? GT is equal to what? 0. So how do you make T solve the formula? So take this one here. I want to have U sine theta is equal to what? Half what? GT. Multiply all 2 by 2. I would have what? 2U sine theta is equal to GT. Then the Bible starts by G. So T is equal to what? 2U sine theta over G. This one is what we call the time of flight of the motion. This is at this point A now. The time to get from A to B is what we call what? This from A to B is what we call time of flight. Now, the time here of flight here is equal to 0. That's this one. While the time of flight is at point A. Time of flight at point A is equal to 0. Time of flight at point B is equal to what? Which is the time it takes from where? From the level of projection in this case now to the level of projection. The time it takes from what? From the point of projection to return back to the level of projection. Or the time it takes from where? For a projectile to travel from rest to rest is what we call the time of flight. The maximum height is the what of a projectile is the highest height reached by a body when the body is projectile. So when the body is projected, the highest height reached, the vertical what highest height reached by the body is what we call the maximum. This is what the maximum height. I told you this one is called the range. This one is called the what? The time of flight. So this one is called time of what? Of flight. Time of flight. So take note of this one. Take note of this. Take note of this number 2, which is what? Number 2. Take note of this number 2 too. Number 2. Take note of this number 3. And take note of number 4. But what about the time, this time from here to this place? What about time to get to this point, to the magnon? Time to what? To reach what? The maximum height. What is the time to reach, to get from A to probably C? Just what? The time to reach maximum height is equal to the total time divided by 2. So if you divide this time of flight from the time to from A to C is the same time from C to B. Why? Because the body is projected from the same level. The same level. Your H1, H0 is equal to H1. Your initial position is equal to final position. So that means the time, small letter t, time to get to A to C is time from A to C is equal to what? If you divide this one by 2, I would have what? U sine theta over G. So that is the time to reach the maximum height. Time to reach the maximum height, that is the time. So I've given you what? The range. I've given you what? The what? The range at maximum points, maximum height. But the question they will now ask you in the exam, which is very important for this kind of projection. At what point with what? What will be the longest horizontal range, horizontal distance that this body can experience? What is the longest horizontal distance that this parabola can experience, that this projector can experience? The longest what? Horizontal what? Distance. It occur at theta equal to what? The longest horizontal distance occur at theta equal to what? 45 degree. It occur when theta equal to what? That means the longest what? Horizontal what? Distance, or the maximum what? Horizontal distance occur when what? Theta is equal to what? 45 degree. Please take note of that. So the longest horizontal distance, that means if you have two what? Competition, we have two persons to what? To be involved in a shot put. And one makes a what? An angle of 30. The other one makes an angle of 60. Another one makes an angle of 45. The one that makes an angle of 45 degree will be the one to travel farther. That will move further. That means to say, the one that threw at 45 degree will move a little further. The one that threw at 45 degree will have the longest horizontal range. So what is that? Range normally is equal to what? U squared sine 2 theta over G. So what do we do? I need to check my mic. What do we now have? U squared sine 2 times 45 degree. What do we have? Over G. So if that is your what? Your angle now that you have substituted there, don't forget this angle of projection. This one 2 times what? This is what? Velocity of projection. 2 times 90 is what? 45 is 90. Sine 90 is 1. Sine 90 is equal to 1. Therefore, R max is equal to what? U squared over G. Now, what is your U? U is the least what? Velocity of what? Of projection. So this U is what? Your least velocity of projection. When theta equal to what? 45 degrees. Called least velocity of projection, or the minimum velocity of projection is what we call U. Your G is 9.8 and all that. So this one, let me call this one equation what? This one is 5. This one is 6. So two questions you have. And then the question is that at what is the angle at which range will be minimum when theta equal to what? 0. Excuse me. At what angle will range be what? Minimum when theta is equal to what? 0. Range will be minimum when theta equal to 0. Or at what angle will range be equal to 0? Better that way. At what angle will the range, angle of projection will the range be 0 when theta equal to what? 0 or 360 or 180 degree. So range can be 0 at what? 180 or 0 degree. Because when you put 180 here, 2 times 180 is 360. Sine 360 is 0. If you put 0 here, 0 times 2 is 0. Sine 0 is 0. Everything becomes what? 0. So I believe I've done case 1. This is case 1 where you require all these 5 major formula. You understand? If you can calculate your what? Your range from this formula. You can calculate your time of flight. All these formula will not be relevant for what? For case 2. Because this case 1 where I talk about the motion of a parabola, of a projectile of a parabola, is what? We are assuming that it started from the level of projection and returned back to the level of projection. But in case 2, we are going to be more, a little bit, improve on the taking it from a higher height to the ground level, projecting it from the ground level to fall on a particular height. So that's what I want to be looking at that in the class, the second class that I want to see again on this channel. Thank you very much. God bless you. I hope you enjoy the projectile. Ensure what? Those area of what? That motion of what? Projectile motion of, as a parabola. If you don't understand that place, you can rewatch it again. But as a JAM student, you can neglect that part and take this formula that is most important. Or as a O-level, very O-level student, but A-level student, you will require that what? Equation to know the latus rectum of a parabola and know your what? How the equation is gotten, and know your formula that it is what? 2u squared cos square what? Theta over what? Over G. The minus sign indicating that what? It is what? it is a parabola, and it has that formula. That from that formula of parabola, you can get that equation from it, from that lattice from it, which is 4a. Thank you very much. God bless you for watching, and ensure you subscribe if you are a returning viewer. You are just watching my video for the first time, and if you are a returning viewer, thank you for watching. God bless you and stay safe. Thank you.